write an equation for the line. So lines have the form y equals mx plus b, where m is the slope and b is the y-intercept. Before I determine the slope, I'm just going to go with writing the equation of the line because then it's easy. So our y-intercept where it's crossing the y-axis is crossing at 4, correct? Positive 4, so it's a plus 4. Everybody comfortable with that? And then our slope is the rise over the run, as I heard some of you saying, which is true. It's the change in y over the change in x. So here's another whole number point. To get from one point to the next, we went up 2 over 1, right? Yeah. And we're walking uphill. It's a positive slope because if we from left to right started to walk, we'd be walking uphill. So if that happened the other way, if it was like this, we'd be walking downhill. That'd be negative. But it's positive, so it's 2 over 1x. So we would write y is equal to 2x plus 4. Questions on that? So our slope is 2. Questions? Okay, pretty easy. Good job. I think most of you got it right. Okay, so say we're doing average rate of change. We're filling in. Here we go. Okay, so average rate of change over an interval. So if you know how to find the slope, you can find the average rate of change. It's very similar, but it's not always going to be slope. But I'm going to show you how they relate because they're very similar. So the slope between 2 points, you can find it by doing the rise over the run, or you can look at the change in y over the change in x, which really the formula for that is y2 minus y1 all over x2 minus x1. It's probably been a while, but how many of you remember somewhat seeing that formula back in the day? Okay, awesome. So y2 minus y1 all over x2 minus x1. So that's if we have 2 points. So here's our first point, x1, y1. Here's our second point, x2, y2. So to find the slope between those 2 points, you do y2 minus y1 over x2 minus x1. So let's find the slope between these 2 points. xy, xy. Here's the important thing, you guys. It doesn't matter which point is first and second. So, which x value is smaller? 2. So think about it. If we were to graph this, guys, we'd go over 2 up 5, right? Then we go over 3 up 8. Which point comes first? The 2, right? So your smallest x values. This is our first point. This is our second point. Because they won't always necessarily put them in order. In fact, especially on the secondary 3 level, they might not put them from least to greatest just to see if you are paying attention. So to find the slope between these 2 points, we do y2 minus y1, so 8 minus 5 all over x2 minus x1. So 8 minus 5 is 3 over 1, which is 3. So the slope is 3. Well, that also would have been the average rate of change. So it's pretty simple. So here's the formula for the average rate of change. So you're asking, well, you just said it's the same thing as a slope. Why don't they call it slope? Because we have to be able to find the average rate of change for any function. Do all functions have slopes? No, right? Don't quadratics have accelerations? Don't square roots have accelerations? So it's not, that's why we don't say, just find the slope. Because it's not always going to be slope. But it does work the same way. So to find the average rate of change on an interval from A to B will just be the x value. So from this x value to this x value, from A to B. We're finding the average rate of change on this interval from A to B. It's this formula, f of b minus f of a, all over b minus a. So I'm going to say that again. Our function at b minus our function at a, all over b minus a. So it's actually very similar to finding the slope. These tend to be hard for students at first, but if you realize you're just finding the slope, then you'll hopefully see it's easy. So let's think about it, guys. You don't need to write this part down, but let's think about where this formula makes sense. If we have an a value, I told you that was my smallest x value, right? Okay, so a, isn't this y, f of a, the function at a? Right, everybody? So wouldn't that be x1, y1? Are we all comfortable with that? And then this is x2, because that's our largest x value. B is our largest x value. So that would be b comma f of b. That's just x comma y, because b is x2, and then f of b means our function at b. So that's a y, that's y2. So that's y2 minus y1 all over x2 minus x1, which is f of b minus f of a all over b minus a. So is everybody comfortable with that? A is your smallest x value, b is your largest x value. You're just finding the slope, basically, but it's not a slope necessarily. Okay, so here we go. First example. Find the average rate of change for this function. F of x is equal to 2x minus 4 on this interval. So this is going to be a slope because this is a line. Well, let's just do it using the average rate of change formula, which is the slope formula as well. My a value is 0, my b value is 7. Questions on that? Okay, so I say to myself, average rate of change. Automatically, I know that's the formula. F of b minus f of a all over b minus a. So to be able to do the formula, I need f of b, I need f of a. So let's find it. So we know a, we know b. So can we find f of a? Doesn't f of a just mean what's our function at a? What's a? 0. So what's my function at 0? Can we just plug in 0 to find it? Okay. So that'll be 2 times 0 minus 4, which is negative 4. So f of a, you guys, is negative 4. Now we need f of b, which means my function at b, which means my function at 7. So we'll be doing 2 times 7. 2 times 7 minus 4, right? 10, right? 14 minus 4 is 10. So now we'll do our formula. So f of b is 10. So keep in mind, we need f of b, f of a, and b. So f of b is 10 minus, now look at f of a, because there's a lot of subtracting negatives, you have to be really precise. But I expect you, my secondary 2 kids did this worksheet the other day, I expect you to not make these kind of errors. So it's 10 minus, what is f of a?
Negative 4.
Negative 4, all over b, which is 7, minus a, which is 0. So 10 minus negative 4 would be 14, right?
Yep.
All over 7, which is 2. So guys, the average rate of change on the interval from 0 to 7 was 2. There was only an average rate of change of 2 between 0 to 7. Does that make sense, everybody? Okay, let's do another one. Okay, find the average rate of change for this function. 3 minus 2x squared on this interval. X is equal to negative 2 and x is equal to 4. So this is not a slope, but nevertheless, same formula. It's f of b minus f of a all over b minus a. So here we go. So this is my a value. A is negative 2. Now notice it's not written on an interval. You can see it written in 2 different ways. It says x is equal to negative 2 and x is equal to 4, but that's the same thing as on an interval from negative 2 to 4. Questions? Okay, so a is negative 2, b is 4. So now to do the formula, I need f of a, which means my function at negative 2. So with parentheses, anytime we substitute something in, we use parentheses. So 3 minus 2 times negative 2 squared. Let's calculate that. What's f of a? Let's all practice typing it in, not watching everyone else. Here we go. 3 minus 2 times parentheses, negative 2 squared, negative 5. Does everybody get negative 5? Okay. Then f of b means my function at b. So that would be 3 minus 2 times 4 squared. I'm substituting in b, which is 4. So we'll have 3 minus 2 times 4 squared. Type it in exactly as you see it. Negative 29. So now we can do our formula. F of b, which is negative 29, minus f of a, which is negative 5, all over b, which is 4, minus negative 2, minus 8. Is everybody comfortable? Am I confusing anybody? So negative 29 minus negative 5 is negative 24. And on bottom we have a 6, so that's negative 4. My average rate of change from negative 2 to 4 is negative 4. Okay. So my question for you is this, guys. So this is really important. Okay, so that means there was an average rate of change of negative 4. That's okay. So is this a larger average rate of change, or is this a larger average rate of change? So I didn't say what's the larger number, what's the larger average rate of change? Negative 4, right? Average rate of change means the average rate of change, the average distance, rate of change between those 2 points. So this is actually a common mistake, is people will say, oh, well 2 is larger than negative 4, so this must be a larger average rate of change. But this changed by positive 2, and this changed by negative 4. Which one's larger? Negative 4, right? Does everybody understand it? But it does come down to the context of the problem. If I said to you, what's the larger average rate of change, you'd choose negative 4. If I said what's greater, we would have chose 2. Does that make sense, everybody? Questions on that? Okay. Okay, do we need another one like this, or are we okay? I don't know.
Do one more.
Maybe one more, and then, okay. So it says find the average rate of change of this quadratic on this interval. So a is negative 1, b is 1. So to do the formula, we need f of a, which is f of negative 1. So we're plugging in negative 1. So we're going to have negative 1 minus 2 squared plus 4. So you got to be really precise when you type it in. You got negative. Yep, negative 5. So f of a is -5. Then f of b means our function at b, which means our function at 1. So we'll have -1 minus 2 squared plus 4. What do we get?
3.
Correct. So now we'll do f of b, which is 3, minus f of a, which is -5. Don't mess up on negatives, because a lot of people will say, so 3 minus 5, because they get in head. But make sure you write 3 minus, then look at f of a, which was -5. All over b, which is 1, minus a, -1. Do you see how you can make a lot of errors with science, but you can't, because you guys are in secondary 3, so I expect you to not. So on top we get an 8, on bottom we get a 2, so that's 4. So my question is the average rate of change greater for this function on this interval, or for this function on this interval? They're the same. Way to go. Good answer, guys. -4 and 4 have the same average rate of change, right? Okay, sweet. Okay, next one. These are the easiest ones. They tend to be the hardest for students, so pay attention. Think about it, guys. Think on an advanced level here. It says find the average rate of change for this function on this interval. So between -8 and -6. So guys, a is -8, b is -6. I need f of a, which just means what's my function at a, right? Doesn't that just mean what's my function at -8? Well, let's look. What is my function at -8? What value is my function at -8? 5. Does everybody see how at -8 there's no function except for boom right there? Does everybody understand that?
Yes.
So 5, f of it, -8 was, so f of a was +5. Is everybody comfortable with that?
Yeah.
So then it says, so we need f of b, which means what's my function at -6? So let's find -6. Any function here? Nope, 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 nope. Boom, right there. There's my function at -6. It's at -3. So f of b is -3. So now I can do the formula f of b, which is -3, minus f of a, which is 5, all over b, which is -6, minus a, which is -8. So on top we get a -8, and on bottom we get a +2. So our average rate of change is -4. So guys, between those 2 points, the average rate of change is -4. Are we all good with that? Okay. Last one, then I'll give you lots of time to work. Find the average rate of change for this function on this interval. These are the easiest ones of all. So we're given this. Isn't this the same thing as having an equation, as having a graph? Yes, it's just no table of values, right? So my a value would be -3. My b value is 1. So to do the formula for average rate of change, it's we need f of a, we need f of b. So let's think about it. Doesn't f of a means what's my function at -3? Okay, what is my function at -3? -8.75. What's my function at b? Which once again means what's my function at 1? Is -7.75. So now we can plug it in. F of b, which is -7.75. Oops, minus f of a, which is minus -8.75. All over b, which is 1, minus a, which is -3. Good. So on top, we're going to get a cross the line, change the sign, whatever you want to call it, a 1. And on bottom, we get 4. So the average rate of change is 1/4 on the interval from -3 to 1. Okay? Questions? That's the average rate of change between those 2 points. Okay. Sweet. You do 1 through 13. Find the average rate of change. We're going to have a quiz on it tomorrow. Yeah. It's really, I couldn't have seen it without doing the formula. On average, that there was a change of 1/4. Yeah, you can kind of see it. But it's on average, remember. It's not constant.
Okay.
Yeah, good question. Okay, so 1 through 13. You might need a separate sheet of paper. I did. Quick! You guys will want to watch, I promise, okay? So it says, what's the area of the shaded region below? Given that the average is 12 and the standard deviation is 2. So we have this normal curve, right? Don't we know the percentages for a normal curve? So isn't this 34%? You gotta have this memorized forever. Then this is 13.5%, right? 2.35, 2.35, and then 0.15, correct? Percent. So it says, what is the area of the shaded region? So what do we add up? 34% plus 2.35%, right? Plus 0.15%. Are we all comfortable with that?
Yes.
Okay, next one. We'd add those up. It says, what's the amplitude and period? Very important. It's been a while. What's the amplitude?
1/2.
Good, 1/2. Remember that these have the form A sine of B theta, right? Where A is the amplitude, B is the number of cycles from 0 to 2 pi. Okay, so our amplitude is 1/2. Then our period is not 2. Do not say it's 2. Period is 2 pi divided by B, right? So 2 pi divided by 2. Isn't B 2? So our period is pi. Are we all comfortable with that?
Yes.
You might see it on the quiz tomorrow. Next one. Write an expression for h of x if h of x is equal to f of x times g of x. Okay, so we're writing h of x as equal to f of x times g of x. Well, f of x is a line. Can't we write the equation of a line? It's going to slope -1. And it's crossing at -3. So negative x minus 3, right? Negative 1x minus 3. So now h of x is f of x, which is that, times g of x, which is that. So h of x, so I'm going to write h of x is equal to f of x, which is negative x, minus 3 times g of x, which is x squared minus 2. Everybody comfortable? We distribute. I'm not going to take the time to do that. Are we all good at that? So if I said f divided by g, then it would have been, or if I would have done g divided by f or f divided by g, either one, then we do division, right? Then we'd have to factor and see if they simplify. Does that make sense, everybody? Okay. Next one, simplify and state the domain restriction. So we're simplifying and stating the domain restriction. So we're doing f of a over g of a. So f of a is 2a squared minus a minus 3 all over g of a, which should have been a plus 1. Okay, so this is f of a divided by g of a, but in secondary 3, we expect you to be able to simplify that. So I say I need to factor everything, so we can only divide out exact factors. So we're looking for what multiplies to be a times c, which is -6, and adds up to be -1. Wouldn't that be 3 times 2? Wouldn't it be -3, guys? Now, keep in mind, you cannot quick factor your a value in front of x squared. In front of a squared is not 1, so we would have to drop and break. So we drop down the end terms, 2a squared and -3. You break down the middle term as those two things, right? So minus 3a plus 2a. Is everybody comfortable so far? Then you group the first two terms, group the last two terms, and factor out what's in common. What's in common in that group? A. So then divide each term by what you factored out. So that would be 2a minus 3, right? What's in common here? Don't say nothing, there's always a 1 in common, so I'm factoring out 1. Divide everything by 1, left is 2a minus 3. Check your safe haven, are we safe?
No.
Factor out 2a minus 3. So that's divided out because we factored it out. Left was a plus 1. Is everybody comfortable? So our top became 2a minus 3 times a plus 1. On bottom, we have a plus 1. Okay, before you divide anything out, you have to state the domain restrictions. Remember that. Guys, remember, before you divide anything out, state the domain restrictions. Isn't it when the denominator is equal to 0?
Almost.
So a cannot equal what? -1, right? So then our final answer would be, let's divide out their exact factors. So our final answer would be a cannot equal -1 and 2a minus 3. So 2a minus 3 as long as a does not equal -1. Does everybody remember that? It's been a while ago. Okay, find the solutions. This one's probably a harder one, so I just want to give you a hint here. Find the solutions. Doesn't that just mean solve? Guys, I really think you need this.
Yes.
So that's why I'm doing it. Okay, finding the solution means solve, right? I don't like to build fractions when solving, so I'm going to cross multiply. Is everybody okay with that? I'm going to multiply both sides by x minus 1. Now, doesn't it divide out over here? So we have x squared minus x plus 2 is equal to 2x squared minus 2x, right? Now it's quadratic. To solve a quadratic, you have to get it equal to 0. So I subtract x squared, I would add x, and I would subtract 2 to make it 0. Does everybody understand that? That all became 0. on this side. 0 is equal to 1x squared, and then plus 1x, nope, minus 1x, right? Minus x, and then minus 2. And then we solve a quadratic by factoring our quadratic formula. Your guys is on your paper, I'm not going to lie, it's going to be quadratic formula.
Yeah.
Okay. Find the inverse of the function, state the needed restrictions. Whenever I say find an inverse, what's our first step? Switch x and y, guys. If you don't know how to find an inverse, we can't move you on next year. So switch x and y. So wouldn't that be x is equal to negative 5 over y minus 1? Solving for y algebraically, there's a couple different ways to do this. Pay attention, watch. Algebraically, I'm an algebra junkie. Isn't this x over 1?
Yeah.
So can't I flip both sides to bring y up to the top?
Yep.
As long as you do it to both sides. So that's 1 over x is equal to y minus 1 over 5. Now isn't solving for y pretty simple? Multiply both sides by 5. So don't you multiply straight across. 5 over x. What?
How can the negative?
Oh yeah, they're still negative. We'll multiply by, negative 5, right? So we'll multiply by negative 5. That would be negative 5 over x is equal to, that divides out and becomes 1, right? So y minus 1. So then when we add 1. So our final answer will be negative 5 over x plus 1 is equal to y. Now our y's alone. We found the inverse, so we'll write f inverse of x is equal to that. I don't want to rewrite it again. Are we all comfortable? Okay, it's been a while. That's why I want to go over it. The rest of the time's yours. Ready, set, go. Ready, set, go.